When we are seeing like this, it is having 5 number of carbon atoms. That's why we'll be considered as that one only parent chain. When it is having diethyl or dimethyl, you should not consider for di, tri, tetra for in the alphabetical order. Okay, the number which is the position of the substituent or the side chain will be called as locant. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up session 3 from the chapter Organic Chemistry, some basic principles and techniques. So in the last class we have discussed, that is, classification of organic compounds, homologous series and nomenclature of organic compounds. These are the contents we have discussed in the last session. In the today's session, rules for naming branched alkanes, naming of cyclic compounds, naming of organic compounds containing functional groups. Okay. In the last class, we have discussed the straight chain organic compounds and its nomenclature. In this session, we will discuss about the organic compounds containing branches and the cyclic compounds which is having the ring structures and which is containing the functional groups. First, we will see the rules for naming branched alkanes. Okay. First rule is longest chain rule. The longest possible continuous chain of carbon atoms including functional group and multiple bonds is taken as the parent chain. Okay. The longest possible carbon containing or carbon atom group or which is having multiple bonds or which is containing the functional group will be considered as a parent chain. We will see an example now. See here, it is a complete compound. See, 1, 2, 3, 4. 4 carbon atom is present means we will call it as but. All are single bond. That's why we will call it as ane. That overall compound name is butane. Okay. Why we are considering this only means, see, it is the longest chain. We can tell 1, 2, 3. Like this also, but it is having only 3 carbon atoms, it is having 4 carbon atoms. That's why we will consider this longest chain as a parent chain. Okay. So the overall compound name is butane. See here another example. 1, 2, 3, 4, 5, 6 one side. 1, 2, 3, 4, 5. Which is the longest chain? This is the 6 carbon atom having the longest chain. That's why the arrow mark is showing here. 6 means hex. The overall alkane, that is ane. Hexane is the parent chain. If we see the another molecule which is having a wide branch, 1, 2, 3, 4, 5. You can tell like this also, 1, 2, 3, 4, it is small. 1, 2, 3, 4, it is also small. When we are seeing like this, it is having 5 number of carbon atoms. That's why we will be considered as that one only parent chain. The overall parent chain is pentane. Okay. If there are 2 chains with same number of carbon atoms, then the carbon with more number of substituents is considered as the parent chain. See here 1, 2, 3, 4, 5, 6, 7. Again 1, 2, 3, 4, 5, 6, 7, 8. Whatever the number is having the same number of carbon chain, but wherever the substituent is there, from there we have to start at the numbering. Next is lowest number rule. That was the longest number rule which is having the more number of carbon atom, that should be considered as parent chain. But what is this lowest number rule? The numbering of carbon atoms is done in such a way that the carbon atom to which side chain or the substituent is attached should get the least number. This side chain or the substituent should get least number. Okay, see here 4 carbon atoms are present. That's why we'll call it but. But from which side we have to count? If you count 1, 2, 3, 4 from the right side, the substituent group will get the 3rd position. Okay, there is another possibility. From if we start from left hand side, 1, 2 means the substituent will get least number. 2, this is 3. That's why this will be incorrect. This will be correct. This substituent attached to carbon atom should get least number. That's why this is completely incorrect. This is correct. From any side we can count, but the substituent or the multiple bond should get the least number. Okay. See here. Another example. 1, 2, 3, 4. Okay. What we'll call 2 position. For the second position, methyl is there. First position name, position number 2. This is methyl group, methyl. This is butane. Like this, you have to name the organic compound. The number that indicates the position of the side chain or the substituent is known as locant. Okay, the number which is the position of the substituent or the side chain will be called as locant. Next is rules for numbering the carbon chain having more than one side chain or more than one substituent. Numbering of carbon chain is done in such a way that the sum of the numbers given to the carbon atoms carrying the substituents should be minimum. Means lowest sum rule will be considered here also. See here, we can start up counting here. From here 1, 2, 3, 4, 5, 6. Okay, overall 6 carbon atoms are there. Here also from this side also 6 carbon atoms. But the number of positions, if you count, here second position, here third position. If you start counting from the right to left, this is fourth position and this is fifth position. Which is the least number? This is the least number which is containing the substituent. This is third, this is fourth, this is fifth and this is also fifth. But here one number which is having least and the overall 10 is there. That's why that is correct. And here overall 11, this is incorrect. The position, if we keep on counting, you should get the least number. Here the 10 is the least comparative to 11. That's why the rules for numbering of the carbon atom should be have a least number. Next, in case there are 2 or more similar substituents are attached to parent chain, their positions are indicated separately and prefixes such as di, tri, tetra are used. See here, it is a normal carbon chain. Okay, position is written, everything, we know that. But what is the difference here? This is also methyl, this is also methyl and this is also methyl. All are same functional groups. That time what we have to do? We have to name the position number 2, 3 and 5. How many? 1, 2, 3. That's why tri. What are the functional groups? Methyl. This is methyl. Number of carbon atom 1, 2, 3, 4, 5, 6. That's why hexane. 2, 2, 3, 5. Trimethyl hexane. When we have to add like this, when the functional groups or substituents should be same, that time you can name like this. Next is, if identical groups are present on the same carbon atom, then the locant number is repeated. See here, normally carbon atom 5 are there. Okay, the locant position is substituent position is second position it is present. Okay, the lowest number is also following here. But both the side on the same locant number, same substituent is there. But then also you have to repeat the number 2, 2 because one side 2 here, another side 2 here. 2, 2, same substituent, that's why di, 2 common substituent are there. Again, what is the substituent name? Methyl. What is the carbon number? Pent and ane. 2, 2, dimethyl pentane is the common or it is the name of the organic compound. See here, the first point of difference rule, if the carbon chain is long, then the set of lowest number at the first point of difference is it violates the lowest sum rule also. What does it mean? Means the overall 9 carbon atoms are present, but you have to count the locant side. First time from the right to left, 2, 4, 7, see here, 2, 4, 7 is present and also here 3, 4 and 8. 3, 4, 7, 3, 4, 8 and 2, 6, 7. Both will come 15. But which one is the least? 2 is the lesser than 3. That's why we will consider this is only correct. That's what they are telling. It is correct because the first point of difference is 2 is lesser than 3. Okay. Next one, rule for arranging the different substituents. The names of different substituents present in the parent chain are named in alphabetical order. Prefixes like di, tri, tetra are not considered while arranging the substituents in the alphabetical order. Okay, what is that? Rules for arranging the different substituents. See here, normally numbering of carbon atom and the position of substituents. Now, overall after the numbering or the considering the longest chain, everything has been done. Now, what you have to do means, this is methyl, right? This is 2 carbon atom, that's why ethyl. Okay. Now, 3 ethyl, 2 methyl hexane. Why 3? First ethyl only we should get. E will come first, then M. In a alphabetical order, you have to name. That's why at the position 3 ethyl group is there, 3 ethyl. Second position methyl is there, 2 methyl hexane. When it is having diethyl or dimethyl, you should not consider for di, tri, tetra for in the alphabetical order. Okay. Only you should consider the substituents group. That is only the rule which we are following here. See here, overall heptane, 7 carbon atom, 1, 2, 3, 4, 5, 6, 7. Okay, that longest chain we are considering here. And at the 4th position and the 3rd position and 4th position and 5th position is having the substituents. That's why 3 ethyl, 4, 5 dimethyl heptane. But we are not considering this di in a alphabetical order. If you would have considered, this D will come first, this E will come next. No, we are considering only the substituent alphabetical order. That's why 3 ethyl, 4, 5 dimethyl heptane we have written. Okay. Naming the complex alkyl substituents. If the substituent on the parent chain itself has a branch chain, then it's named as substituent alkyl group inside the bracket in such a way that the carbon atom directly attached to parent is assigned number 1. What they are telling? See, this is the longest chain. For that substituent group is attached. That substituent group is only in a branched structure. That time what we have to do? That substituent you should write in a bracket. Okay. This is heptane. At the 4th position, there is a substitution. 4, open the bracket, 1, 2, 3. 1 methyl and ethyl is present. That's why 1 methyl ethyl heptane or 4 isopropyl heptane. Iso means branched in a straight chain. That's why you can write like this also. But in a IUPAC nomenclature, you can write like this also. You have to write in bracket when the substituent only completely branched. See here another example. This is the overall heptane. They are considering 1, 2, 3, 4, 5, 6, 7 and here the 3rd position substituent is present. Here also 1, 2, 3, 3rd position substituent is present. That's why 3 plus 5, 8, 3 plus 5, 8. Okay. Which is incorrect and which is correct means this one is correct and this one is incorrect. Why? Because 3-methyl, 5-ethyl heptane, one side you have to consider which is having the alphabetical order. 3-ethyl and 5-methyl you have to tell that it should be in a alphabetical order. That's why it is correct. 3-methyl, 5-ethyl is incorrect. If the sum of the locant is same from either side, then the substituent which comes first in the alphabetical order gets the lowest number. Okay. Till now we have seen the naming of the branched alkanes. Now moving forward to the naming of cyclic compounds. Cyclic compounds are named by adding the prefix cyclo to the names of alkane having the same number of carbon atoms as in the ring. For any kind of cyclic compounds, cyclo should be added. See here, 1 carbon atom, 2 and 3. We know that 3 carbon atoms means propane. But this cyclo name should be present. Here 4 cyclobutane, here 5 cyclopentane, 6 cyclohexane. See here 1, 2, 3, 4, 5, 6. This is hexane. Okay. Cyclic in structure, cyclo. This stick means methyl. We know that methyl. Same 2 substituents are there. That's why dimethyl. What is the position? 1, 2. That's why 1, 2 dimethyl cyclohexane. Okay. See here. 1, 2, 3, 4, 5. Pentane. In cyclic structure, cyclopentane. This is ethyl and this is methyl. So first one what we have to get? Ethyl only we should get because E is the first alphabet. Later M will come. 1 ethyl, 3 methyl will form. Here also same 1, 2, 3, 4 butane, cyclobutane, and this is little bit branch. That's why at the third position 3 propyl, dimethyl. This one is methyl, this one is methyl. 1, 1 dimethyl, and third position propyl is there. That's why 1, 1 dimethyl, 3 propyl cyclobutane. Next one, if the side chain contains more number of carbon atoms than those in the cyclic ring, then the compound is considered as a derivative of alkane and the ring considered as a substituent. Okay. This is more number of carbon atoms rather than the cyclic ring. That's why this is a substituent for this one. So you have to tell one at the one position cyclic is there, 1 cyclobutyl, overall butyl, pentane is there. That's why it's the longest chain rule. That's why it is correct. You can write 1 pentyl cyclobutane. This is wrong. This is correct. See here 1, 2, 3, 4 butane. This is 1, 2, 3 propyl. Cyclo at the second position. That's why cyclopropyl butane. Here see 1, 2, 3, 4, 5, 6 hexane, that is cyclohexane. Here 1, 2, 3 propyl, 1 methyl propyl, 1 here methyl, here propyl. That's why 1 methyl propyl cyclohexane. We'll see naming of organic compound containing functional groups. In that long chain is there, numbering of parent chain is also present. Then parent chain is the one which has functional group directly attached to it even if longest chain rule. Whatever the length of the carbon chain or the parent chain, functional group will be attached directly to it. So numbering of parent chain, the numbering should be done in such a way that the carbon linked to the functional group gets the lowest number even if it violates the lowest sum rule or locant rule. When the functional group itself contains the carbon atom, then that carbon is assigned number 1. Whatever the carbon atom is attached to functional group, it should get the least, means it should get the first number rather than which is not containing the functional group. Naming of compounds with polyfunctional group. If there in more than one functional group present in a compound, then one of the functional group is chosen and the remaining functional groups are treated as subordinate functional groups. The functional group with higher priority in the sequence given below is termed as principal functional groups. This is the functional group priority. It should be written in a decreasing order. It is written in a decreasing order. While you are naming or nomenclature doing, that time this priority group should be in your mind. Means if this is carboxylic acid, this is sulfonic acid, this is ether, this is ether. From carboxylic acid to alkyl or aryl group, till that it should be there. This is carboxylic, sulfonic, ether, carbochloride, This is amine, cyanide, aldehyde, ketone, hydroxyl. This is amide, this is amine, and here alkene, alkyne, halogen, nitro, alkyl. These are the things you have to given in a priority when naming of the organic compound. This table should be, or this series should be in your mind. If it is present with the carboxylic acid, then aldehyde, your priority should go with the carboxylic acid. Later it should be in a aldehyde. See here, this is the group name COOH, carboxyoic acid, carbamyl, formyl, cyano. This is oxo, hydroxy, NH2 amino. These are the prefix and these are the suffix for it. Okay. See here, halo, nitro, alkoxy, alkyl, sulfo, haloformyl, alkoxy carbonyl, and this is sulfonic, oil halide and alkyl OH. These are the prefix and suffix for the functional groups which we have seen in the previous slide. See here, overall pent is there. This is second position, 2 in. How they have given means 1, 2, 3, 4, 5. Right? That's why pentane. Why means this is at the second position, multiple bond is there. That's why you will get 2 in. Pent 4 methyl. Okay. So 1, 2, 3, 4, 5. 4 methyl pent 2 in. Okay. Here 1, 2, 3, 4, 5. This is also pent, but this is oic acid is there. At the first carbon oic acid is there and the fourth carbon hydroxy is present. We know that first carboxylic acid should get the priority, later the remaining functional group. That's why here we will get the carboxylic acid as a first priority and remaining hydroxy as a second priority. So we have to start the numbering from this order only. 4-hydroxy pentanoic acid. Hydroxyl is there, that's why oic acid, this carboxylic acid. If a molecule contains both carbon-carbon and carbon-carbon at identical positions, then priority is given to carbon-carbon while numbering and the name of the molecule should end with "-ine". See here, but 1 in 3 ine, because this is overall but, this is ene and ine. Okay, this carbon-carbon bond should get the first priority. Next is nomenclature of substituted benzene compounds. Benzene is a 6-membered cyclic compound with alternate single and double bonds. It is represented in any of the following ways. See here, 1, 2, 3, 4, 5 and 6 carbon atoms, overall surrounded with hydrogen. But what is the thing is, alternative double bond should be present, because to satisfy the valency, it is a complete overall cyclic nature. You can write like this or like this, and in a resonance structure you can write like this also, internal also cyclic nature. Naming of the monosubstituted benzene. If the benzene ring is having single functional group, it is derived by adding the name of the substituent with the word benzene. Substitute plus benzene, substituted benzene. For example, see, this is benzene attached to methyl. That's why methyl benzene. Benzene attached to bromo, bromobenzene. Benzene attached to nitro, nitrobenzene. See, you have to observe here, these are the functional groups which will be used as a prefix. Methyl, bromo, nitro. These are all prefix attached to benzene. So, we have to name in such a way only. See, here monosubstituted benzene with common names also. C6H5CH3. C6H5 means benzene attached to CH3 methyl benzene. The special name is toluene. This is benzenamine C6H5NH2. So, aniline. This is C6H5OH. We'll call IUPAC phenol. It is also phenol. Here also benzene carbaldehyde. Okay. but we can call it as benzaldehyde also. Benzene carboxylic acid, benzoic acid, methoxybenzene, this is OCH3 attached to benzene, anisole. Okay, these were the carbon compounds which is having the ring structure attached to some of the substituents with having special names. Next, if the functional group is attached to carbon chain connected to the benzene ring, then benzene ring is considered as substituent and is prefixed before the root word as phenyl. You can tell it as a phenyl also, C6H5. See here, 3-phenyl propanol, 3, 1, 2, 3. At the third position 3 is there. This is aldehyde, that's why al. 1, 2, 3, 3-phenyl propanol. This is 1-chloro, 2-phenyl ethane. Okay. Next, naming of disubstituted benzene. If the benzene is having two functional groups, that time how we have to name. If the substituents are same, in such a case, the relative position of the substituents must be indicated by adding the symbols ortho, meta, para. What is ortho? 1, 2 position. What is meta? 1, 3 position. What is para? 1, 4 position. See here, 1, 2 is ortho, 1, 3 is meta and 1, 4 is para position. What is this means? 2 and 6, 3 and 5 or ortho and meta. In the trivial names of nomenclature, the terms ortho, meta and the para used as prefixes to indicate the relative positions of 1, 2, 1, 3 and 1, 4 respectively. See here, 1, 2 dichlorobenzene, you can tell it as ortho dichlorobenzene. You should have the sense that 1, 2 will be the ortho position and this is 1, 3 meta-nitro. 1, 4 means 1, 2, 3, 4 or 2, 3. Same thing. Para-benzene disulfonic acid. Okay. If the two substituents are different, the substituents are written in the alphabetical order. See, 1-bromo-4-iodobenzene is okay, but it is in a para position. But at that time, you should see which is the alphabetical order comes first. B is first, that's why bromo and next iodo. See here, chloro, nitro, first will come chloro, then will come nitro. 1 chloro, 3 nitro, benzene. You have to see the alphabetical order with the different substituents. If there are more than 2 substituents are there, the numbering is done such a way that it satisfied the lowest sum rule. Okay. First one, bromo, methyl and chloro. 1 bromo, 3 chloro, 2 methyl, benzene. And here 4 chloro, 3 nitro, 1 benzoic acid. Okay. The carbon atom to which carboxylic group is attached is given as the lowest priority, which is the same rule we are following, the carbon containing functional group. The highest priority should get the least number. That's why here carboxylic acid will get the least number rather than the others. See here, 1, 2, 3, 4. This is the functional group. That's why we'll get 2-ol. And this is overall carbon atom 4. That's why butanol. And here 3-methyl pentanone. This is ketone. At the second position only you should get. This is amino. Okay. This is alcohol. That's why 2-amino ethanol. Okay. See here, 1 bromo, 3 chloro, cyclohexane. First you have to see the alphabetical order. Here methoxybenzene or anisole you have seen in the special name case. Okay. What we have discussed today is the complete nomenclature of organic compounds. In the last session we have discussed about the straight chain and today we have discussed about the branched and cyclic compounds with having monosubstituted, disubstituted and different kinds of functional groups. What are the things which have given the rules from your textbook? Those completely with the various example we have discussed today. So in the next class we will discuss isomerism and different kinds of isomerism, fundamental concepts in organic reaction mechanism. Okay. I hope you have understood completely what I taught today. So we will meet in the next session. So keep watching our videos. Thank you.